Okay, here we are with a series from Core Pure 1 Part 2. In Part 1, we talked about the first two of the formulas on the screen here, and I said you've got to remember them. And I'm really going to say that you should be able to remember these, but they are not in the formula book. However, the next two are in the formula book, which is nice. You could try and remember them. You probably use them enough that you will remember them, but they are in the formula book. And that is that the sum of squares, so that is 1 squared plus 2 squared plus etc. up to r squared, is actually equal to 1 over 6 n plus 1, 2n plus 1. Actually, a nice fact there that means that n plus 1, 2n plus 1 must be divisible by 6, because this has to be a whole number. It's a nice little exercise if you want to try and prove why is n plus 1, 2n plus 1 divisible by 6. There is a way that you can do that. And the sum of cubes, so which is 1 cubed plus 2 cubed plus ... all the way up to r cubed, is equal to 1 over 4 n squared, n plus 1 squared. And I'm just going to say and repeat myself, these are in the formula book. However, you can prove them, and you will, using induction, which you will cover later in this book. I've talked about it with a couple of you already, but Proof by Induction, Chapter 8. So we can do everything very similar to what we did in the previous examples. So, for example, the same thing, that if we did have the sum from r equals 1 to 9 of r squared plus r, then we could split this up, or maybe 2r squared plus r. We could split this up into 2. The sum from r equals 1 to 9 of r squared plus the sum from r equals 1 to 9 of r. And this would become 2 times, in brackets, 1 over 6 times 9, open brackets, 9 plus 1, 2 times 9 plus 1, using the formula that I just said, plus, and this is n over 2, n plus 1, so this will be 9 over 2, 9 plus 1, and then blah, blah, blah. And I'm not actually going to finish the example. These are relatively okay. I'm going to jump to some of the slightly more trickier examples. So I'm going to have a look at this one. You can pause it at this point and have a go at yourself. How can we simplify this? And I want it in factorized form at the end. So I guess I could make this into a show that question. I'm going to. I want to show that this is 1 over 6, which you might think was kind of familiar from the formula, 2n plus 1, 7n plus 1. Okay, well, that seems like a little bit mysterious where that 7's coming from. Okay, so the first thing we're going to remember is that we can split this up into 2 parts. We can split it up into the sum from r equals 1 to 2n of r squared, take away the sum from r equals 1 to, and let's be super careful about it. So if I was going through the terms, 1 ... n plus 1 ... 2n, I want from n plus 1 up to 2n. So I want to get rid of 1 to n. So I want to get rid of 1 to n of r squared. So this one is the formula that I just did. So it is 1 over 6n, n plus 1, 2n plus 1. And this is the formula, the same formula, but wherever I saw n, I need to write 2n. So this is 2n instead of n. It is 2n plus 1 instead of n plus 1. And it is 2 times 2n plus 1 instead of 2n plus 1. And this is where my thing that I said from before really is so important. It's very tempting to expand both of these cubics in n out and try and factorize afterwards, and you will have a real pain when trying to factorize these cubics. So instead, factorize, factorize, factorize. Let's write that on the screen. Factorize. I'm going to label the point. Factorize, factorize, factorize. I hope I made that point clear. Okay, so let's have a go at this. So this is, let's kind of simplify it out a bit. So I have got, going to keep it because I can see this factor of a sixth out and I can see it in the answer as well. So I'm going to bring immediately out this factor of a sixth. That's the first factorizing I'm doing. And I've got 2n plus 1. And then I've got 4n plus 1. And I'm taking away, I factorize out the sixth, n plus 1, 2n plus 1. And sometimes, to make it really clear, I like to kind of put a square bracket outside of a big factorizing that I've done. So now I can see that I can factorize out common terms. The common terms I can factorize out here is I can factorize out this n from here and here. And I can also factorize out 2n plus 1 from here and here. So I can bring them right out the front. So I have got n, 2n plus 1. That's good because I can see that in my final answer. And then left in the square bracket, I have got 2 times 4n plus 1 minus n plus 1. I'm hoping that's going to become 7n plus 1, which is a sixth n, 2n plus 1. And now left in this bracket, I have got 8n plus 2 minus n minus 1, being careful of that minus, which is equal to 1 over 6 n, 2n plus 1, 7n plus 1 as required. So factorizing was super useful. Okay, one last example for this chapter. So how am I going to tackle this? I need to show this. Definitely going to be doing factorizing. Going to look at this and I'm going to try and split it up. So the left-hand side is equal to the sum from r equals 1 to n of r cubed minus r squared. Because if I multiply that out, I can see that I can change this into two equations that I know. So this is equal to the sum of r equals 1 to n of r cubed minus the sum from r equals 1 to n of r squared. So substituting my two formulas in, I have got a quarter n squared n plus 1 squared minus a sixth n plus 1, 2n plus 1. So I can then see what are the common factors. Well, n, but just one of those in the first one, and n plus 1, just one of them in the first one. So I'm going to factorize out that. Kind of not quite sure what to do with the quarter and the sixth at the moment, but I think they're going to become this 12 up here. Well, I know they will, but just at the moment, I would factorize out the n and the n plus 1. And then what have I got in my big square brackets? Well, I've got a quarter n, n plus 1, one of those left, plus a sixth, 2n plus 1. Right, I am going to take out a 12th now, but you want to kind of be really careful. Now, you can be led by what you're aiming towards to make me think to take out a 12, but we've got to be really careful to see what we're going to actually be left with inside if I take out a 12. So, I think I'm going to do it the ultra safe way, and that is to use equivalent fractions. So, a quarter is 3 over 12. And a sixth is 2 over 12. And that means it's much easier for me to take out my 1 over 12 here. You might have been able to shortcut this, but this definitely was a lot safer. Now I'm hoping what is inside the brackets is going to become 3n squared minus n minus 2. So let's see if it does. (3n squared) plus 3n. Oh, aha, mistake. Would have been, I've spotted it. There was a minus sign from here all the way back there, so I'm going to do it in a different color. That should have been a minus, that should have been a minus, that should have been a minus. So now I've actually got a minus here. 4n minus 2. And finally, this gives us 1 over 12, n plus 1, 3n squared minus n minus 2 as required. And if you do examples like that, that's pretty much it for this chapter. Definitely do a lot of practice and definitely, as I said, factorize. So back to suggested questions. These are the suggested questions. There'll be a homework coming up soon on this, and opportunity for you to ask for help. But that is it for now.